Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and his brother Joel Chaiken. We're here to help you figure out how to approach SAT math questions. So here's a question from the non-calculator section, and it is a free response. So we actually have to answer it. In the triangle above, the sine is that. What is the cosine? So this is a geometry question, although one could argue that sometimes sine and cosine are algebra also. And let's see, the sine of x is 0.6. So that makes the sine is the opposite over the hypotenuse. And they're asking, what is the cosine of x? So the cosine of x is just going to be this value. Not use x. I'll use the letter, what do we say? C. Okay? C. So we need to find C because the
Notice
sine...
that you carefully chose 1 to be the length of the hypotenuse.
Yes, I know. That was a clever trick, wasn't it? That gets back to this concept of the unit circle. It's very, very helpful because, see, that this is the sine is the opposite over the hypotenuse. This is a right triangle, by the way. Sines and cosines only work, and tangents only work like this in right triangles.
Yeah.
And then the definition of the sine is the ratio between the side opposite the angle and the hypotenuse. So I conveniently chose it to be 1.
Now, I think what we both recalled in our minds but didn't say is I'm going to draw the diagram. Here is the unit circle. There's the center. If you have any angle, and we draw the horizontal axis and the vertical axis, and draw the radius for any angle, and the angle here is theta, and we choose the circle to have radius 1. What you need to memorize is that in this figure where you take the unit circle, a unit radius, 1 radius, an angle, the perpendicular to the point on the circle where the radius ends, and draw the perpendicular, and then also to the horizontal axis, and draw the perpendicular to the y-axis. Okay, that gives us this distance. Let's call it S, and it gives you this distance, which we'll call C. Okay, and the the definition, in other words, what the trigonometric functions are. We have 2 trigonometric functions here. The sine of angle theta is that distance, which I marked S from here to here, which is the length of this line. That's S.
The height.
And the height. And the cosine is the length going from here to here, which I marked as C.
So Seth.
And so you have to know this, and then you fit the given triangle into this main fact about what sine and cosine are. You put in the measurements that you could choose to deal with sines and cosines. You scale it all so that hypotenuse has length 1 to match this circle, and then put 6/10 because they tell you that the sine of the angle is 6/10, and then the length of this line is the unknown, is the cosine.
Okay, Seth.
So let's find C.
Seth, going forward, when you do that analysis, we should do the question more quickly so that people who just want to know the answer get it, and then the background.
Well, the answer is 4/10.
No, it's 8/10. What are you talking about?
Yeah, all right, say it's
first
8
of all,
tenths. Okay.
first of all, going. We should talk about.
We can make guesses. Yeah, if we want quickness, we
so,
could give guesses. We can give wrong guesses.
Going forward, when we do like a deep analysis, we should get the answer on there so that we should have, so the people who are watching this can just see the answer and then stop the video.
Well, people who don't know this are never going to get the answer.
I know. So they'll keep watching. We don't have to. Okay. Anyway, let's do it. Okay. Fine.
All right. So solve it out.
Okay. Now. Okay. First of all, now that we did that stuff, now let's just solve this thing. So there are different ways to do this. This is a triangle in use of the Pythagorean theorem. Notice I said that I wrote the 6/10 as 3/5. And you could also write this as a 5/5. And people should recognize that there's a 3-4-5 triangle in the house. Oh, this is called the Pythagorean triple. If this is 3 and this is 4, then this hypotenuse is 5. This ratio satisfies the Pythagorean theorem. And it does for really even like 8, 6, 10 also does. So this is a 3-4-5 Pythagorean triple. So one can recognize immediately that C is equal to 0.8 because the 0.8 is in the ratio of 3-4-5. Or you could realize that 6/10 is 3/5. You change this to a 5/5, and then you recognize that this is a Pythagorean triple. You have, and Zeitlord froze. You have the 3 on the sign. See, the 3 is in the so annoying that this thing froze. God. Okay. See the, please, 3. See the 3, the 5. So this is going to be a 4/5. So the answer is 4/5 or 0.8. I'm sure on the SAT you could answer it as either 4/5, 0.8, or 8/10. They'll probably accept either of them. And you could double check this. You could check the Pythagorean theorem. 0.8 squared is 0.64. 0.6 squared is 0.36.
Well, they don't have
this
calculators.
Adds up to 1. I know, but 0.8 is 60.64. 0.6 is 0.36. They add up to 1. There's so many ways.
Let me verify. Let me verify that 3, 4, and 5 are a Pythagorean triple. I wrote it out.
Seth,
5 squared is 25.
Yes, they are.
And presumably, it equals the 3 squared, which is 9, plus 4 squared, which is 16.
Right.
And you add them up.
Right.
You add them up.
Yeah. So
you add them up, and wow.
Yeah. Okay.
9 plus 16 is indeed.
We know
yes,
this.
it is indeed 25.
Yeah, we know that. Okay. So the thing is, the bottom line is, once you draw this picture, then it's really up to you. And there's so many ways to get the 0.8, the Pythagorean theorem, recognizing it's a 3-4-5. But those are really the only two ways. And you should really know those 3-4-5 triangles. And then you ask yourself, what are the other triples that come up on the SAT? Well, there's the 3-4-5, which, by the way, you can multiply this by any number. And here is actually multiplied by a fraction. And then there's the 5, 12, 13 Pythagorean triple that you should know going into the SAT. And then the 7, 24, 25. And then there's no, it's not 8. It's, it's 8. It's 8. No, wait, oh God. No.
Yeah. Well, you can guess, but you need to, you can always verify it.
Right. And then
you don't remember them.
It's 5, 12, 13, 7, 24, 25, and 8, 13, 64, 169 is, what's 64 and 169 is 3. No, there's 5. Yeah, it's a 15, isn't it? I'm going too fast. 64 and 169 is 5 and 4 is 13. 1. What? No, there's an 8. What? This is crazy. What am I?
I don't know.
Hey, it's not 5, 12, 13.
Well, who's going to remember those other Pythagorean triples?
Well, yeah. Oh, you should. You should. How could I be crashing like this? It's 25 and 144 is 169. So it's 3, 4, 5. 5, 12, 13. 7, 24, 25. And there's an 8 one. It's 64. how could I be doing this? This is insane. How can I not remember that? But there's one with an 8. 8. We gotta stop this video. We can't waste people's time. But there's an 8 one. So I'm really sorry. What's the difference between 864 and 225? It says 225 minus 64. No, I don't know. This is really embarrassing. Yeah, I don't know. Okay, anyway, we gotta stop. So anyway, that's the bottom line. Yeah, so this is a trigonometry question. And you really have to know, it's really helpful to know the Pythagorean triples, but also you have to know the definition of sine and cosine. And you have to be ready to draw a triangle. And then plaster in, as Seth said, plaster in what the sine and the cosine are. And it's really helpful in trigonometry to make that hypotenuse a 1. And that's the essence of the unit circle, which you've probably seen in other Algebra 2 classes. Seth, have you found the 8 one yet? I don't remember what it is. It's really embarrassing. Anyway. Okay, everyone. We sort of crashed here on figuring out that last Pythagorean triple, but I'm sure you know it, and you could just Google it. Okay, but the most common one on the SAT is going to be the 3, 4, 5, and the 5, 12, 13, and any multiples of those. And this is a multiple. This problem here is a multiple of 3, 4, 5. What they did here is they multiplied it by 0.2, right? Yeah, they multiplied it by 0.2. 3, 4, 5 times 0.2 is 0.6, 0.8, and 1. And that's what's going on. Okay, Seth, what are you doing?
I'm trying to work out again. There's a general formula for generating the Pythagorean triples.
But did you know? So Seth, you didn't know the 3, 4. Were you? If I said 3, 4, what would you have said?
5.
Oh, so you do. Okay.
Oh yeah, I know the first one.
Yeah, but Seth, let me ask you that question. Why did you, after your explanation, why did you say the answer was 0.4?
Because I forgot to change 4/5 into 8/10.
Oh, so you knew the answer was 4/5, and then you made
the answer was 4/5, and I knew that I had to convert that to tenths. And I forgot to multiply the 4 by 2 to get it to be 8/10. So I said 4/10.
Got it.
Yeah,
okay.
That's all.
Okay, good.
Yeah.
Okay. Okay, so you recognize it as 3, 4, 5 because what scared me.
So the takeaway points are to relate sines and cosines. The Pythagorean formula, which I wrote in the case of 3, 4, and 5. The meaning of sines and cosines in terms of a triangle, and then the standard high school curriculum memorization of the simplest or the smallest Pythagorean triple, which is 3, 4, and 5.
Right.
I don't know. Is it fair game on the SAT to get people on the higher Pythagorean triples like 5, 12, 13?
I would say 5, 12, 13 you should know. And by the way, I do have it. It's 8, 15, 17. Okay?
Yeah.
That's the one I forgot.
Yeah.
8, 15, 17. Okay?
Yeah.
I would say 8, 15, 17 is not going to come up, but the 3, 4, 5 and the 5, 12, 13 you should know. And the 7, 24, 25 is a cute one.
Yeah.
Okay.
Okay, another piece of knowledge you need to deal with in here is the concept of similar triangles, and relating similar triangles to scaling. Notice that. What they did do, they gave you a unit triangle by telling you that the sign, what they tell you,
The
the
sign was
sign was 6/10
right.
in decimal. The problem would have been a little bit easier if instead of writing 6/10, they wrote 3/5,
Yeah.
which would surely remind more people that there's a 3 and there's a 5, there's a right triangle. So please bring to mind the 3, 4, 5 Pythagorean triplet. But
That's
no, they gave
true.
you 0.6. Okay, another piece of math knowledge you need to know is that 0.6 is, don't think of it as 0.6. It is 6/10. And that is a fraction. In simplest terms, it is 6/10 is equal to 3/5.
Right.
I remember, here's a memory from childhood. I grow up and watch my parents pump gas from the gas pump, and it showed the gallon count and the money count in decimal. So like it would be like start off with point 0.1 gallon, 0.2 gallons, 0.7 gallons, 3.2 gallons, 3.5 gallons, 3.9 gallons. As a kid, okay, so it's point. My parents told me that those numbers had points in them. But it was only when I went to school that the teacher taught me that these point things are called decimals, and they really are fractions.
Wow.
And then another memory I have is that this is a memory that most people don't have at all. Those were the days when the pediatrician, the doctor for kids, when you had a cold, or a more serious seeming disease like a cough or a stomach ache, the doctor would actually come to your house.
Yeah.
Right? And my parents would take my temperature, and they say, "Oh, you have a temperature of like 99.1." The doctor would come. He took the temperature, and he said, "Oh, your temperature is 90 and 1/10," which is the way the teacher in school read decimals.
Wow.
Yeah.
Wow.
So I was impressed because the doctor used a mathematically informative way of reading decimals.
Wow.
Yeah.
Yeah. That's pretty cool. Okay.
Okay.
So Seth did mention this whole thing about the similar triangles, so that you could have written this as 3/5 as well. That would have given you the same thing. 3/5. Notice that these triangles are exactly the same. 0.6 and 1. They're in the same ratio. These are similar triangles. So you could have written the 0.6 as 3/5. You could have also have written it as 6/10. And that would have worked too. This could have been the 6/10. Then you would realize this is 8. If that's 8, then the cosine is the ratio of the 8/10 or 0.8. Again, there are a million ways.
What we're talking about is we actually didn't show you two non-identical similar triangles. But what I think you have in mind is as follows. Here's one triangle.
God, what a mess.
Okay, here's one triangle.
How can anyone see anything here?
Can you see that?
I can't see anything. What are you talking? Oh,
it's on the gray spot.
The action is on the upper
right-hand corner. Here's a little
left,
triangle.
upper left.
And here is a big triangle.
Okay, hold on. There. Okay.
Right? A little triangle, the big triangle.
Yeah.
This little triangle has a hypotenuse of 1. It has a base of of what should we say?
0.8.
4/5
Okay.
and a height of 3/5.
Okay.
It is similar to the big triangle, whose hypotenuse is 5,
Right.
whose base is 4,
Yeah.
and whose height is 3.
That's right. Yeah.
So these are two. They're not drawn to scale because this is certainly not drawn to be 5 times. If
Right.
it were 5 times as large as this one, it would be like this. Which
Right.
is.
Yeah.
But these two triangles. This is a familiar 3, 4, 5 right triangle. It is similar to a 3/5, 4/5, 1 triangle.
Right. Right. And similarly,
And it is the triangle with hypotenuse 1, who is the one that reads off for its base and its height, the cosine and the sine.
Right.
Right.
And what's nice about similar triangles is that we're looking at these blue angles. It's the sine is the ratio of the sides. So the sine of the blue dot is 3/5, and it also is the same as 3/5 over 1, which you can see this is 3/5 over 1, this is 3/5. So in similar triangles, the ratios of the sides are the same, and the sine and the cosine are a ratio. They are a ratio between the sides in a right triangle.
Yeah, each one is a ratio.
Each one is a ratio. They are ratios. They relate to relation. And every single 3, 4, 5 triangle in the world, no matter how big or small it is, has the same ratio and therefore the same angle, which frankly we don't know, but we don't care.
Oh yeah, 3, 4, 5. Right. Yeah, exactly.
We don't really care what the angle is. It's
great. Yeah. It's not a neat angle like degrees.
Oh God, I hear it through the internet. People are screaming to know what angle that is. So I do an inverse sine of 0.6, and that happens to be 36.86989765. It's about 36.9 degrees.
Yeah.
That triangle. Okay.
I know. Well, should we tell them that triangle, the 3, 4, 5 triangle, is different from the 30, 60, 90 degree triangle?
No, we shouldn't.
Well, the 30, 60, 90 triangle is another triangle that's popularly used in the SAT.
Yeah, really popular. Are you kidding me? Really popular. Why is it really popular?
They even tell you about it,
it's
right?
even on the cheat sheet. It's even on the I mean that one you really got to know because their questions come up on this.
There
one.
it is.
So here you can tell
the special right triangle.
So here you could see that the sine of 30 degrees for everyone, people, the sine of 30 degrees is a half. How did I know that? Because it's x divided by 2x, which is a half. And the cosine of 30 degrees is x radical 3 over 2x. So it's radical 3 over 2. This stuff you should also know.
Yeah.
But they give it to you.
They really should have told you. They should have given you they should have reminded you of the other of the third special triangle of today, which is the 3, 4, 5 triangle.
No, because that's not a special triangle with respect to angles.
Really?
That's a special triangle with respect to sides.
This is special with respect to integers and with integer length sides, and these are special with respect to neat relationships between the angles.
Right.
Yeah, the 30-60 triangle, the 60 degree angle is twice the angle as the 30 degree angle.
Right.
In the 45 degree triangle, we have a right triangle whose acute angles are equal.
Right.
They're equal to each other. These 45 and 45 are equal. 60 and 30, 60 is twice 30.
Right.
Okay?
Yeah.
But the ratios of the sine and the cosine are hard to symbolize numbers.
Yeah.
For the case for this triangle. Yeah.
Okay, at some point we will hit a question.
Except the cool thing, though, the cool thing about this triangle is that the cosine of 30 degrees is a half.
No.
Sorry. No. Sorry. The sine of 30 degrees is a half.
Right.
Yeah.
Right. And it's worth it really is worth your brain to memorize that. It really, really, really helps in trig problems to just know. Say sine of 30, you say a half. So it's really
well. I have trouble with that. If you memorize that there's a 2 here and a 1 here, and you forget what's over here, you could say what's over here is the square root of 2 squared minus 1 squared, which is the square root of 40 of 4 minus 1, which is the square root of 3.
Right.
So that will enable you to recall. If you remember the characteristic that the height is half of the hypotenuse, then you could refigure out that the base is the square root of 3,
right,
divided by the square root of 3. The base is the square. The base, if the hypotenuse is 2, the base is square root of 3.
Right. Everybody has their own cute way of remembering it. That's how Steph remembers it. I remember it by memorizing the sine of 30 as a half, and then I remember the cousin's name. Everybody has cousins, John and Jill, or Jackie and Alice, whatever, right? So I remember what's the cousin to a half? What's the number that goes with the half? I just remember it's radical 3 over 2. You tell me something has a sine or cosine of a half, I'll tell you that the cosine or the sine of that angle is then its little cousin, radical 3 over 2. So they go as pairs. 1/2 radical 3 over 2, radical 3 over 2 and a half. So, and then I just go from there. So everyone has their own cute little tricks of remembering. But yes, if you totally forget everything, you could just write a triangle with this proportion and then use the Pythagorean theorem and really get the other side as radical 3. So many ways to do these problems, which is good.
Okay. Guess we did that.
Totally kill this. I'm sure no one has gone this far in the video. If you have, I hope you got something out of it.
Very patient.
Yeah, very patient. I hope you got something out of this, how to deal with trig things. It is important. These things do come up. Okay, everyone, have a great day. Please like us, dislike us, give us comments on our YouTube, our videos, and you can email us SAT Math Questions at satmathquestionoftheday@gmail.com. Have a great day, everyone. Bye.
Bye-bye.